So we're going to graph linear inequalities. The first thing you have to do, the first thing you have to be able to do, the first thing you need to be able to do is graph a line. I do accept Starbucks gift cards as bribes. So one example of a graph would be to graph the line x is less than 2. To graph x is less than 2, you first want to graph x is equal to 2. Graphing x is equal to 2, remember that all x equals are vertical lines. So drawing a graph of x is equal to 2, it would look something like there's a grid, and x equals 2 would be, a line, right, vertical line passing through x equals 2. Now, we're graphing the line x equals 2, but I actually wanted to graph x is less than 2. So one way to do that is to look at the number line itself and say, if this was just a number line and I was graphing x is less than 2, I'd put an open circle on 2 and I'd shade to the left. Well, the equivalent of an open circle is I want to put a dotted or a dashed line. That really was 2 T's. I want a dotted or dashed line. That's like an open circle, and that's used for less than or equal, or less thans or greater thans. That's why I kind of made that a dotted line. And then we want to shade, like we did with the number line, to the left of that. I'm going to do these with lines that are parallel, because later we're going to want to crisscross lines and see what they look like when they intersect with other parts. So that is a visual representation of my solution. What is your solution? Your solution is this. Sometimes I circle the whole thing to direct your attention there. So let's do another example of something like this. If I want to graph y is greater than or equal to negative 3.5, I'm going to first graph y is equal to 3.5. Much like all vertical lines, or all x equals are vertical lines, all y equals are horizontal lines. So I'm going to do a horizontal line, a positive 3.5, that would be right here. So I'm going to do something like this. Now, I tend to represent y equals with vertical number lines. So if this was a y equals number line, and I had 0, and oops, this is negative 3.5, not positive 3.5, so I need to drag that down here. If I had 0 right here, and I had negative 3.5, and I wanted it to do greater than or equals to, I'd put a solid circle, and I would shade all the way up. So the equivalent here is to do a solid line of y is equal to negative 3.5, and to shade in a direction that means greater than. It means the numbers are getting bigger, not smaller. And that would be your solution. So a third example would be to do, we'll call this example 1. This is kind of the real example. Y is less than negative x. When we do y is less than negative x, we're actually going to graph the borderline of y equals negative x. I'm going to call that a borderline. Y equals negative x is the same thing as saying y is equal to negative 1 over 1 x plus 0. Why did I write that in that funky sort of way? Yes, Brandon, I used the word funky. I know m is equal to negative 1, and my y-intercept is 0, 0. So when you graph this, since my y-intercept is the origin, and I'm going down 1, right 1, or up 1, left 1, I'm also making it, if I look at the inequality, it's a less than, and that means dotted. So I'm going to do a dotted line. I'm also, like we did, going to make sure that I pass through all the integer points. So I'm going to make sure I'm doing the up 1 over 1 all the way from the top left to the bottom right. Now we have two methods to figure out which direction of the graph to shade it. Method 1. Method 1 is to take the inequality as is with y on the left. This says y is less than a negative x. Less than for y means down. So I'm going to look at this graph and I'm going to shade below it in this direction. Method 2 is to test a point. If I test a point that's not on the line, like maybe if I test the point -1, -1, and I plug that in, plugging in the point, plugging in for x and for y, I get -1 is less than a -1, or -1 is less than 1. -1 is less than 1, that is a true statement. Since it's true, that means that this point has to exist in the true area. This point exists right here, so wherever that point is, since it's true, we shade with side with the true is. We follow that. We'll do an example later where we test a point and it's in a false region and see what that means. So, our next one, y is greater than or equal to -2 x minus 4. To start, we want to graph y equals -2 x minus 4. We graph it with a solid line. We graph it with a solid line because we have a greater than or equal to. So we're going to go through our steps here on how to do this. Number 1, graph it as a y equals. Number 2, we're going to check if we do a dotted or a solid line. 3, we're going to test a point, or we're going to have it as a y is less than, or y is greater than, or y is less than or equal to, or y is greater than or equal to. So if we start this process and go, okay, I know how to graph y equals -2 x minus 4. -4, y-intercept here. -2 is up to left 5, or down 2 and right 5. Connect. And then we have to figure out where to shade it. Oops, actually didn't work.
You know, it's like 90% of what.
Okay, drawing's having issues because it's so close to the edge of the paper, but you get the idea. Okay, so now we have to figure out what side of the line is shaded on. If I go back to the original, it's a y is greater than or equal to. Since it's greater than or equal to, we're going to shade above the line. Another one is to figure out, okay, we're going to test a point that's not on the line. So I'm going to test the point 0, 0. It's the easiest one to test, and it makes sense here. So if I test 0, 0 and plug it in, I get 0 is greater than or equal to -2/5 times 0 minus 4, or 0 is greater than or equal to -4. That is true. And if I graph wherever this is, I say 0, 0 is here, and since it's true, and this is true, and I'm testing this point, I want to shade where it's true, where it all matches. So that works. My next example is to graph 2x minus 3y is greater than 6. If I graph that, I'm going to first want to solve it for y. So I have -3y is greater than -2x plus 6. And remember, when we divide the left and right sides of an inequality by a negative, we switch the sign. So I have y is less than +2/3 x minus 2. That's the line that I'm going to graph. I'm not going to write it again as an equals, since there's really no point in that. But let's go -2 up to right 3, down to left 3. It's going to be a dashed line. So we're going to shade it as a dashed line, or draw it as a dashed line. And then I have to figure out which side to shade it on. One of two ways. The first way is to say this is a less than, which means down. The second way is to say we're going to test a point that's not on the line. I'm going to test 0, 0. And it's best to test it back in the original problem. So we're going to test 0, 0 in the original. Because that way if you made a mistake somewhere else, you're checking in the original problem. Okay, so I plug in 2 times 0 minus 3 times 0 is greater than 6. And I get 0 is greater than 6. That is false. 0 is not greater than 6. 0 is less than 6. So, since that's false, and I tested the point 0, 0, that's a false, I want to shade not where that point is. I want to shade on the other side of that point. You never want to shade on a false, you always want to shade on a true. So, regardless of which way you worked, we're shading down. And that is the end.